Hello students, in this video we are going to do problems based on composition of function and inverse of a function. Okay. Now move on to exercise 1.3, page number 18. Question number 1. You are given let f is from 1, 2, 3. F is from 1, 3, 4 to 1, 2, 5. So f is defined from this. Okay. F. Now, G is defined from 1 to 5 to 1, 3. So, this is G. Now, how is it going? F is equal to 1, 2. What does it mean? 1 goes to 2. 1 go to 2. And then 3 comma 5. So, 3 go to 5. And finally 4 go to 1. This is your function f. This is how it is defined. Then how is g defined? Just look at it. 1 comma g is equal to 1 comma 3 means 1 go to 3. 2 comma 3. What does it mean? 2 also go to 3 and 5 goes to 1. So this is how the function g is defined. You are asked to calculate G composition F. G composition F. So we are going to do G composition F for each element. Okay. Now you know G composition F of x is nothing but G of F of x. Now we are going to find for each element what is going to happen. So first let us do G of f of 1 because 1 is the first element. So f of 1 is what? 2. So this is G of 2. And what is G of 2? G of 2 is 3 because 2 is going to 3. So G composition F, if I order it as ordered pair, 1 go to 3. Same way, we are going to find G of f of 3 because 3 is the second element. This is G of, what is f of 3? 5. And what is G of 5? Is 1. So where does 3 go to? 3 go to 1. And finally, G of f of 4. What is f of 4? Where does 4 go to? 1. So this is G of 1. And where does 1 go to in G? 1 goes to 3. So 4 comma 3 is the G composition F. So you have to list it like this and say G composition F is 1 3, 3 1 and 4 3. Hope it is clear for you. Now we move on to problem number 3. Listen carefully. I'll do the first part. F of x is equal to, f of x is equal to modulus of x and g of x is equal to modulus of 5x minus 2. I am supposed to calculate G composition f of x. So G composition f of x is G of f of x. This is G of, what is f of x? F of x is nothing but modulus of x. G of modulus of x. What is G of x? If x is there, it is 5 times x minus 2. Now modulus of x is there. So 5 times modulus of x minus 2 inside the modulus. Okay. That is G composition f of x. Now let us do f composition g of x. What is f composition g of x? Is f of g of x. This is nothing but what is g of x? I am supposed to copy this, which is modulus of 5x minus 2. And what is f of x? I need to put the modulus, that's all. And no, 5x modulus of 5x minus 2 modulus. No need to write 2 times modulus. So this is just 5x minus 2. So we calculated g composition f. We calculated f composition g. Sometimes g composition and f composition g are equal and sometimes they are not. In this case, they are not equal. Sometimes they will ask you to show G composition F is equal to F composition G. But it is not true for all the questions. So do not think the answers will be same. Okay. Now, moving on to question number 5. I did the first part only. Second part you can do it in the similar way. State with the reason whether the following functions have inverse. Okay. So what is the rule for inverse to exist? The function should be 1, 1 on 2. Both should be there. It should be a bijective function. So first question, let us see. Where is f from? 1, 2, 3, 4 to 10. 10 is the codomain. Okay. And how is it defined? 1 go to 10. 1 go to 10. And 2 go to 10. 3 go to 10 and 4 also go to 10. Is it a 1, 1 on 2 function? Is many going to 10? Yes, it is a many one function. Therefore, inverse will exist or not? It will not exist because only for 1, 1 on 2 function, inverse exists. Moving on to subdivision 2. You are given G is from 5, 6, 7, 8. And 2, 1, 2, 3, 4. How is it defined? 5 go to 4. 6 goes to 3. 7 to 4. And 8 to 2. Okay. It is actually, looking at the left hand side, domain, it is many one. Why is it many one? Because 5 and 8 together go to 4. And also it is an into function because 1 is left out. Okay. This is actually many one on 2 because nothing is left out. But you in the codomain, actually you should have 1, 1 as well as on 2. But this is neither of them. Therefore, for this also, inverse does not exist. Is it clear for you? So when a function is given to you, you just need to check whether it is 1 to 1 or on 2, 1 to 1 and on 2. If both are there, inverse exists. If not, inverse does not exist. Okay. Now we are going to do a problem in which we have to find the inverse and show that the function is invertible. This is a board question which has come many times in the board, only with the numbers are changed or sometimes with same number also. So please concentrate and read the question number 9. Consider f is from r plus. R plus means only positive real numbers. Okay. To minus 5 comma infinity. Sorry, infinity, never square bracket because nobody knows the value of infinity. And you are given f of x is equal to 9x square plus 6x minus 5. You want to show that f is invertible and you need to show that find the inverse also. So you need to show f is invertible and you need to find the inverse. So let us find the inverse to start with. You remember when you want to find the inverse, f of x is nothing but y, and after writing this you will make x as the subject of formula, which means you will write it in the form x is equal to. It is y is equal to something is there, no? You need to write it in the form x is equal to. Okay. Now, I am going to complete the square here. 9x whole square is 3x square plus, are you able to understand? 6x can be written as 2 times 3x. So a square plus 2ab, because 6x and 6x matched. So I'm just writing 1, because into 1 if I do, it doesn't create any problem. So a square plus 2ab plus b square, which is nothing but a plus b whole square. I added 1 on my own. I should take away 1 on my own. Then only the value will not change. And minus 5 is written as it is. So up to this part, 3x square plus 2x plus 1 the whole square. How much is that? Yes, 3x plus 1 the whole square minus 6. So whenever a quadratic comes, if you want to make x as the subject of formula, you should complete the square and start it. Okay. So y is equal to 3x plus 1 whole square minus 6, or y plus 6 is equal to 3x plus 1 the whole square. Now I want to write it in x is equal to format. So what I'm going to do is 3x plus 1 is equal to square root of y plus 6. Negative square root we are not writing because it is r positive. So what is 3x now? 3x is equal to square root of y plus 6 minus 1, and x will be equal to square root of y plus 6 minus 1 whole divided by 3. So we have found the inverse. See, it is matching with the book answer. Okay. So we have found the inverse, but you need to show that f is invertible. That is left out for us. Okay. F is invertible. How will you show f is invertible? There are two ways to show. Already we discussed one way. You need to show f is 1 1 and f is on 2 you need to show. This we have already dealt with the problem. Another way of doing is g composition f of x is x you need to show, and f composition g of y is equal to y you need to show, where g is the inverse function and f is the function. Okay, now we are going to follow this second one, because already we have done an example with proving 1 1 and on 2. Also you know how to prove 1 1 and on 2 clearly. So now we move on to prove that f is invertible. Listen carefully. Let me write the function. F is the function, question number 10, right? 9. F is a function from r plus 2 minus 5 comma infinity, where f of x is equal to 9x square plus 6x minus 5. Now we are going to define the function g. G is from where? It is from this to this it will be, correct? Because f is from here to here means g will be from here to here. So g is from negative 5 comma infinity to r plus, and what is g of y defined as? Just now we calculated the inverse, y plus 6 minus 1 divided by 3. Shall we try? G of f of x, and I am going to check if I am getting the answer as x. What is g of f of x? G of, what is f of x? This whole thing is f of x. So when you want to find g of, what are you supposed to do? I am going to write it in the completed square format because it will be easy for me. This step you had already, always follow that. Okay. Now, what is g of y? Add 6 to y, take the square root. Okay. Add 6 to whatever is available. Okay. So what is available? 3x plus 1 the whole square minus 6 is there. Add 6 to it. Take the square root. Subtract 1 whole divided by 3. So 6 will go away. 3x plus 1 whole square is 3x plus 1. Because root is there, root and square will go, minus 1 divided by 3. So this is equal to 3x over 3, which is equal to x. So I got g of f of x as x. Now I am going to check if I am able to get f of g of x, f of g of y is equal to 1. You have to write one below the other in the exam paper. Do not write in between. Okay. Now I cannot erase the board. That is the reason I am doing in this place. Okay. Now we are going to do f of g of y. What is f of g of y? This is same as what is g of y? This is g of y. So I'm just going to copy it. F of square root of y plus 6 minus 1 divided by 3. Now what is f of x? F of x is, I'm going to use the completed square one. Okay. 3 times x plus 1 whole square. Okay. So let me do that first. 3 times, in x place this whole thing is there. Okay. So 3 times x, then plus 1 whole square. And there is a minus 6. So this 3 and 3 will cancel. Square root of y plus 6 minus 1 plus 1 the whole square minus 6. 1 and 1 will cancel. Square root of y plus 6 and square it, you will get y plus 6 minus 6, which is nothing but y. So I got f of g of y as y. So both the ways I got f composition g is iy and g composition f is ix I got. Therefore, inverse exists and the function is invertible, therefore inverse exists, and the inverse already we calculated in the previous page, and this is the inverse of the function. So whenever a quadratic comes, you need to make x as the subject of formula, means you need to complete the square and then do. Practice a few problems with complete the square so that you become very familiar with it. Okay. Hope it is clear for you. Thank you, children.